Hello, everybody. My name is Amir Abbas, and today I have once again with me Dr. Hassan from Karachi. Hassan, are you able to listen to me?
Yes, Dr. Amir, thank you so much.
Okay,
Welcome
so
everyone.
yeah, we will get started. Let me adjust a few things over here. Let me remove these stickers and other details. So we are here once again in front of everyone in continuation to our session on our programming. And as I uh, announced in the WhatsApp group as well that this will be a shorter session. This is going to be a 1 hour session. We are going to be talking a huge list of packages. And what is a package? A package is a bundle. Is a package bundles together code, data, or documentation and tests, and is easy to share with others. And there are more than 14,000 packages which R has. Uh, so this was something. A few things will repeat from the previous uh, discussion. We were talking about the tidyverse package, and we were discussing some of the verbs or some of the functions from the tidyverse package. And as a reminder, whenever you are loading a package, what you have to do is to first of all install the package, and you will have to install the package with the help of this function, which is install.packages, and then inside. So I will remove the comment from this, and this, if I remove the comment from this code should work, which is that install.packages, and inside the brackets you will have this the name of the package in the inverted commas. And because I have installed the package already, so I will not need to run this code, rather I will just be loading the package. And I will load the tidyverse package, and the second package which I will need for this demonstration is the gapminder package, which has the gapminder data. And again, as a reminder, there will be quite a few things which will be reminder from the previous session, so that we can connect where we left and we can move forward ahead. So just as a reminder from the previous session, when we load the gapminder data package, the data of gapminder is already loaded, and whenever you are going to see a data frame, you can just use this head function to see the first 6 rows of the that data set. You can also use this str function to see the structure of that data set. So what str will do is spell out the different variables and different details related to the individual variable, that what are the types of the variables and how many variables are there. In addition to that, there is another package which is glimpse package. We can not package, sorry, there is another function which is glimpse. You can also use that. I'm not going to run that in the interest of time. And there is another way where you can use the view function to just see the data frame in the form of a spreadsheet. I'm also not going to discuss that because we talked about it in the last session. What I'm going to emphasize today's in the today's session are two uh, functions. One of the function is known as filter, and the second is uh, uh, um, one of them is filter, and the second is select. So these are the two uh, verbs which we call it is they're the part of the tidyverse package, and we'll be discussing mainly about them before we go towards data visualization. And let me see, there are a few comments in. Okay, uh, okay, so there's a question straight away related to why head function gives you the first 6 rows. So as I told you previously as well, the head function is by default, like so whenever we have a function, there's a default setting of the function, right? So by default it will give you 6 rows. That is how it is programmed, right? But if you want to override for whatever reason, like you want to say to head, okay, give me first 10 rows, okay, then what you need to do is to add an argument of n equal to 10 inside this head function, and that will just return the 10 rows and so on. Like you can increase or decrease it by the number which you want. But your question is why it is giving you the first rows, because by default inside the coding uh, when you do not specify it, it means just n is equal to 6. That's how it is programmed. And thanks for asking that question. Okay, so now what I'm interested in talking about filter. What does filter does? It filters your data set and filters the rows of your data set on a particular condition, right? So what you can do here, what I'm doing, let me explain this code, what it is doing. So I'm interested in explaining filter, right? Okay, so let me write it out. So what I'm going to do, I'm going to take the gapminder data set, and from the gapminder dataset, I'm taking the country column, and I'm just asking the question that for which rows country is equal to Pakistan. Okay, and so what does this code do? What this code is doing is it is taking the gapminder dataset and then asking the question within the gapminder dataset that where is the country column equal to Pakistan. Remember that when you are asking uh, like whether a particular condition is true or is equal to like country is equal to Pakistan, you will have to use double equal to sign. And then so this is all this code is doing. But if I do not assign it to anything, it will just run and it will print out what I'm seeing, right? Like it prints out all the rows which are for Pakistan, but and that's not useful for me because I do not I cannot use it later on. So what I'm going to do is to assign this to another data frame, right? And then use the assignment operator. So what I'm just going to get rid of the following code, which is just the repetition of what I just said. And I'm going to run it again. And again, like if I run the head function, it's going to do the same thing, print the first 6 rows of the newly formed data frame. Okay. So, okay, please, if you can zoom your screen, let me try that, or let me get myself out of the way. And as at the same time, what is happening that most of the people are watching these lectures on mobile phone, which I think is also causing the problem. At this point in time, I'm finding it difficult to zoom into my screen. I hope that this will be enough. If it is not, just let me know in the comments. Okay, so I will move forward. Okay, and then in the same way, we can do other types of filtering. We can combine the information from 2 columns, as this piece of code is saying that take the gapminder data and see where country is Pakistan and where year is greater than 1960, and save it to gapminder underscore Pakistan after 1960. And the same way, we can see the head of this data set. So it's something what we are using the same filter command, not a command. You're using the same filter function and using the same to limit the rows on 2 columns. And when I run it, I will get the rows where the data is from after 1960 and the data is for Pakistan. Okay. In the same way, we can also filter on the basis of 2 countries. So what this code is saying is that take the gapminder data set, uh, see where the country is equal to Pakistan and where the country is equal to India. And again, I'm saving it to the data frame, which is Pakistan India gapminder underscore Pakistan underscore India. And when I run this thing and run the head along with it, I'm going to see the data set which has the rows from Pakistan and India. Okay, so this is what the filter function is doing. Okay, now, okay, moving forward, I have a, so another thing which I want to emphasize in this lecture is something which we know as the pipe operator. Now, this thing is known as pipe operator. What is this? Okay, just let me write it down. And this is something is a new concept. I want you people to, I want everybody to understand it. And this is known as pipe. This is which is the percentage greater than sign and then percentage in combination. The 3 symbols in combination. We call it as the pipe operator. And what does the pipe operator does, right? It it passes whatsoever is before the pipe operator to to something which is after the pipe operator, right? So what I'm going to saying over here is take the gap minder data set and do something which is after the pipe operator to that gapminder data set. So right now what I'm saying is take the gapminder data set, pass it to this function, which is the filter function, and the filter function is checking for the condition if the life expectancy is less than 65. So what essentially I'm doing over here is taking the gapminder data set, checking whether the life expectancy is less than 65, and then saving this to another data frame with the life expectancy of less than set gapminder less life expectancy less than 65, and running it. Okay. I hope this pipe operator concept is clear. If it is not clear, I will request you people to clarify it over here, because it's a very important data manipulation concept that you will need to understand before moving forward with other data manipulation strategies. Okay, so I'm because there's no question at this point, but if you are not clear about this pipe operator, which is the percentage greater than percentage sign, please be sure to understand this point, because this is a very important point. Okay, so moving forward in the same way, now I'm going to uh, move towards the second function in which I'm interested in explaining, and that is the till now we have been talking about the filter function, right? And the filter function was to restrict the data set on a particular condition and restrict the rows of the data set, right? But as you know that a data frame is a combination of rows and columns. Now select is going to restrict a data set on a set of columns, right? So what I'm going to do is, as you remember, that if I just for the sake of demonstration, if I print the head of gapminder again, then this has many columns. Okay, this is country column, this is continent column, year column, life expectancy, population, GDP per capita, and population in million, right? So these are the many columns in the country in this data set. So what I'm interested in, for whatever reason, I'm not interested in every column of it, but I'm interested in restricting my data set to a few columns. uh, uh, so I'm interested in restricting it to a few columns, because I just want to remove the mess. You'll in the real life you will encounter a lot of conditions where you will be having a lot of columns, and you will be interested in a subset of those columns. So if that is the condition, right, what I will do, I will use this select function, right? So what essentially I'm going to do is use this data set or data frame, I will call it, right? And then use the pipe operator. Now, what this pipe operator does is it forwards the data set, like it forwards the data set to any function which is after the pipe. And then I use the select function, and I put in the name of the columns which I want to select. For example, I'm interested in country. I'm interested in the column continent. I'm interested in year. I'm interested in life expectancy. I'm interested in these columns, right? So right now, this code is doing, and what this code is doing is taking the gapminder data set and selecting the columns of country, continent, year, and life expectancy. And as again, if I run it, it will print out these columns for the this from this data set, but it will not save it anywhere, right? But I also want it to be saved. So what I will do, I will just save it to another uh, uh, data frame with the name of gap minder, or I will say gap minder some columns, and then I will just run it. So now it has been saved into this new data frame, which is gap minder some columns, and I will just uh, change with the new. I will see the head of the new we made data set data frame, and here it is. You have the first 6 rows from this data frame with lesser number of columns. So there are There is another question. What is the So the question is, what is the difference between pipe operator and simple filter options? So I think I was not able to completely and clearly explain what a pipe operator is. Uh, so filter is a function, and filter uses a particular condition. For example, we said that country is equal to Pakistan. It will check the rows for that condition, and then it will filter the rows on that condition and limit the rows on that condition, right? So filter is a function. Pipe operator is a generic, uh, I would call it you can call it a symbol or an operator or whatever you call it, just like an assignment operator. As we have this assignment operator, in the same way, pipe operator as assignment. What assignment operator does is it assigns everything to something which is on this side, right? It's just like an assignment operator does something like this. But what does the pipe operator does? It's Pipe operator takes like whatever is on the left side of the pipe operator to the right side of the pipe operator, and allows you the programmer to do some function, some manipulation on what is passed to the right side. For example, here what it is being said is uh, gapminder, and take the gapminders data set and then select these columns, and I can go on, like I can even pass it further. Whatever is resulted from here, I can just say, like rather than uh, making it a separate line of code, I can just remove this line of code, right? And then what I can do is, with the help of this code, I can just straight away print it, right? So what I'm going to do is take this data frame, which is gapminder, forward it with the help of this pipe operator. So whatever is there in this gapminder data frame, forward it to the following function. And what is the following function? Select these columns from the gapminder data set, right? Okay. So I've selected these columns, I've removed all of the columns, and then what I'm doing, I'm forwarding whatever result from the operation is, right? And then I'm finding out the head of whatever I was forwarding. And right now, normally within the head function, you will put in the name of the data frame. But here I haven't put in the name of the data frame, because that is already understood when you use the pipe operator. When I run it, it will just print out the same thing, right? So that is how the pipe operator works. I hope it is clear. If it is still not clear, please ask me the question again in the comments. So there is another question. Salima is quite active here. And if we write filter gapminder country is equal to Pakistan, how it is different from? Okay, so gapminder. So first, there are two things which are there in your comment. First of all, when you are saying the first statement, which is gapminder, comma country equal to inverted commas Pakistan. Here you have to use two equal to signs, right? Because if you use a single equal to, that means that you are assigning country equal to Pakistan, which is not what we are intending to do right now, right? So that is the first mistake in your statement, and but that perhaps was not the intention of your question. Your question was that how are these two codes different, right? So if you assume that the equal to sign is the same, there are two equal to signs in both of the statements, then both of them are equivalent. These both of them are equivalent in that case, right? Okay, moving forward. And again, thanks a lot for asking so many questions, and you can keep on asking questions, because that's how I will also get an idea that are you able to understand me or not, or where am I able to teach properly or not, because virtual teaching is kind of challenging, because I'm not able to uh, see a lot of things. Okay, in the same way, we can use the select operator in an opposite way as well, right? In the previous code, what I did, I explicitly wrote the names of the columns which I'm interested in, right? So I can reverse this in logic. And what I can do, for example, there are hundreds of columns. I'm interested in all of them, and I'm not interested in two of them, right? So what I can do, I can use the same code, but I can So I here what I'm doing, I'm taking the gapminder data frame and then piping it, which means that I'm passing it to the subsequent function. And what is the subsequent function? Select. Remember, select is going to do, it is going to select a few columns, right? And then, so what I'm doing is, right now I'm using this negative sign over here, and with this negative sign I'm using the negative sign population, and then negative sign in front of GDP per capita. So what this code is saying is, take gapminder data set and pass it on to the select function, and with this within this select function I have negative sign population and negative sign GDP per capita. So with this negative sign inside the select function, I want the function to remove these columns and keep everything else, right? So when I'm going to run it and then run the head of it, so you will see that all of the other columns are remaining in there in your data set or data frame, but just population and the GDP columns are removed. So this is another way of an inverse way of adopting your work, your data frame. Okay. So that was about the select function, and we use select and filter functions in R. If you are not clear about them, then please ask questions related to that, right? In the same way, we can also use another function which is known as arrange. Arrange is very simple. What it does is that it arranges your data set on the basis of uh, a particular column. Right now, what I'm doing is taking the gapminder data set, piping it to the whatsoever is in the after the pipe, and then arranging it on the basis of the life expectancy column, right? So what I'm going to do right now is, so you can see when I print it out, it is just arranged in the ascending order in on the data frame is at arranged in ascending order on the life expectancy column, right? But if I want to arrange the same data set or in descending order on the basis of the life expectancy column, I just have to uh, enclose this life expectancy column with this DESC uh, function, right? So there is a small modification which I have to make, and then if I run this code, I will be able to arrange this data frame in descending order. And you can see right now, the data frame has been arranged in a descending order. So this was something I think quite easy. Again, there are some other filter options which I've put in the code, and I think you can see more of these examples in your free time, because I've shared the code with the group in the WhatsApp. The last function which I want to talk about in the tidyverse in the tidyverse package is mutate. Mutate is something you want to manipulate the columns and you want to calculate a new column, right? So here what I'm doing is, so I'm taking the gapminder data set, using the pipe operator to pass it onwards to whatever is after the pipe operation, right? And then using the mutate function, and with the help of the mutate function, what I'm doing is I'm calculating this new column which is population in millions, right? And I hope I have the correct number of zeros. If not, then let me know in the comments. But you get the idea, right? So what I'm doing is I'm calculating the population in millions, and that is the result of a mathematical operation where you are dividing the population column by 1 million, and then you are assigning the resultant um, data frame into the same data frame. So what will happen is that you will add a new column to your data frame. You can assign it to a different data frame. You can assign it to the same data frame, but like if you just want to avoid creating a mess and creating too many data frames, you can assign it back to the same data frame, and what will it will do? It will assign a new column to your data frame. I'm going to keep on looking for stuff if it is there. Let me see a few things. Okay. Okay, right. Okay, so from here onwards, I'm going to talk about something which we know. There's another package, as I told you, that in R the functionality is limited to a number of packages, and the next package which I'm going to talk about, it is related to data visualization, which is known as ggplot2 package, and ggplot2 is actually it stands for grammar of graphics, and the basic uh, concept is that you the basic concept of ggplot2 is that as you write any language, so visualization is also a language, and you can use different rules to make a grammar of visualization, right? So these rules will help you to make better graphics and to communicate your graphs in a better way to in different situations. Okay. One important point which you have to remember, and it's a generic point but it is important to mention at this point, is whenever you are making visualizations, there are two self-explanatory objectives which are there for visualization. First of all, you may be exploring your data. For example, in the initial stages of your data analysis, you're doing exploration of your data and you're seeing what is happening in your data, what are different variables which may be correlated to each other, which may be related to each other, and you just want to get a feel of your data, as our teacher used to say. And then next thing which you may be able to do is to explain the data, to communicate the data, right? These may be very quite similar but distinct concepts. For example, in exploration, you might not be very much interested in very much into, like, okay, your graph should look good or things like that. But when you're explaining or communicating to others, then you would want your graphs to look pretty and presentable. So these are the two object you need to be clear about the objectives of your data exploration, data visualization. Okay, now here is the important point, and before I move forward, I think uh, okay, are we creating a new variable? So it is, I think, right. Okay, let me move back to the mutate. There's a question related to mutate over here, and okay, so what mutate is doing, and yeah, it is, as Salima, you rightly said, it's making a new variable in the same data set. So you can, like, use any type of mathematical operation. Like here, what I'm doing, I'm taking the population column, dividing it by 1 million, and I'm getting population in millions. Uh, so that, and you do that with the help of the mutate function. So what this line of code is doing is taking the gap pointed data set, using the pipe operator, passing it to this function, whatsoever is in the right side of the pipe, and what is on the right side of the pipe is this mutate operator, and within the mutate, you are giving the name of the new variable, which you name population underscore in underscore million. You can name in anything, whatever you want, and then you set it equal to the new mathematical equation, which is population divided by 1 million. I hope it is clear, and if it is not, once again, you can keep on asking questions. Okay, so now we're going to go into the ggplot2 discussion. Okay, so the concept of ggplot2 is that that whenever you want to visualize something, for example, if you want to make a graph on the piece of paper, how do you make it, right? You just like you make your graph in steps. You make your graph in step. You will, if you have to make a graph on, let's assume, a scatter plot or a histogram on a piece of paper, how would you do? You would make an x-axis with the ruler, or y-axis with the ruler, and then there's a blank canvas, and then you keep on adding things, like you will add one line, you may add another layer, and so on, right? Um that's the basic logic of the ggplot2, that it keeps on incrementally adding uh, the data to the canvas. So for this demonstration, what I'm going to do is use a data frame which is known as mpg. Right. This is the data frame which I'm using for this demonstration. And just as I told you that whenever you have a new data frame, you can just see uh, what the data frame is. And with the help of the head function, there are different columns. I might know or I might not know what these different columns mean. So what I can do, because this is a data frame which is inside our environment, so I have access to the details of this data frame from inside the R environment, which I've, I think, already opened. So let me just show it to you, if I'm able to do that. So it's a fuel economy data from 1999 to 2008 for 38 popular models of cars. And these are the different um, names of the variables and their explanation. Right. Additionally, what I'm interested in doing, first of all, I want to draw a histogram for HWI variable, which is a quantitative variable. Right. And let me see what HWY stands for. It stands for highway miles per gallon. Right. So what I'm going to do is make a histogram, and you might know, and I think at this stage most of you will be familiar of the fact that histogram is used to visualize a quantitative variable. Um, so what I'm going to do, I'm going to use this ggplot function inside the ggplot package. And the way it works is that, first of all, I'm going to pass in the data set which I'm interested in. Right. This is the name of the data set, mpg. And I'm going to use aesthetic argument inside this data set, and within the aesthetic I'm going to pass in whatever is there on the x-axis. That's all for the time being. Right. And I'm going to save it, this operation, into this variable which is known as p, and let me run this code. Right. So can you guess what will happen right now? Okay, so what I've done, let me print it out. Okay, see, this is an empty canvas which I was talking about. Right. So in the first step, what has been made is an empty canvas, and this is exactly how would you would do when you will be drawing something on a piece of paper. Right. When you're drawing, when you're visualizing a data set, or you're making a graph on a piece of paper. So p, what does p contains right now is, you have used the ggplot2 function and taken the data set and one of the variable from that data set, and you have put it in this aesthetic argument. And uh, and then I'm just printing this, and I'm assigning it to variable p, and I'm just printing it, and it will just print an empty canvas. So I can add on stuff on top of that. Right. So on top of this empty canvas, I'm just adding geom underscore histogram, which will just add a histogram for the variable which I've already specified from the data set which I've chosen. Right. And I'm saving the same variable again to its own self, which means that it is uh, updated itself, and I'm going to print the new variable, the updated variable. So right now you can see what has happened is that we have a histogram on top of the empty canvas. Right. But what is happening right now, there is no pretty x-axis variable, there is no pretty y-axis variable, and there is no title. Right. So what I'm going to do is to take care of all these things. And since till now what is happening is that the variable p has this histogram saved to it. Right. So that is there, but I want the x-axis labels and the y-axis label and the title as well. So what I can do is to take the variable p, add the x label to it. The function is x label, and within the brackets you will have to specify the whatever you want to put on the x-axis label. I'm putting the name of the variable on the x-axis variable label, and I'm using the y label function, or I don't know, like, whether you call it function or not. You just need to add y label to this. Right. And then add uh, count on the y-axis, and finally use this gg title to add the titles to your graph. And when you add everything and just print it out, you'll have x-axis labels, you'll have y-axis label, and you'll have a title. But still, I'm not satisfied because my graph is not very pretty, right? So I'm going to do something very simple but very important, right? What I'm going to do, going to use another package which is known as a plotly package. I can install it with the help of this small code, but I'm not going to install because I've already installed. I'm just going to load it with the help of the library. And this plotly has a very simple function. It has the function which is known as ggplotly. And what you do, like your final plot, which was there, right? This is almost final, but I'm not satisfied with the looks of it. So I want to improve it. So the final plot is assigned to this plot object, which is known as, or variable, which is known as p. So I'm going to take this p, just put it inside the function of ggplotly, and I'm going to run it. And it's automatically going to print something for me, which I'm going to like very much. And I'm assuming that you will also like it as well. Okay. And with this simple manipulation, what is happening is that, let me, I hope it loads. Yeah. Okay. Okay. Just a minute. Yeah, let me do something to reset it. Okay. So right now, what is happening is, look at this graph and look at it, like it is much prettier with one additional line of code. You have just converted into you've just got a very pretty graph. uh, so this is a basic histogram. Okay. Selena has a question. I will just in the interest of time, I will come to that question in the end. We'll continue with this discussion. If you have any questions related to these graphics, please let me know, right? uh, okay, in the same way, now I want to move forward. uh, what I can do over here, now this code is just a repetition of what I did, but it's doing everything in the same line. And let me explain it again. Like, you can do all of it together, right? So what this is doing, this is the first line in which I used the hwy variable and assigned it to the dataset, took the dataset mpg and used the hwy variable and assigned it to and like made an empty canvas out of it with the help of the ggplot object, right? And then I've added the geom underscore histogram to it, right, from this portion of the code, right? Then I've added the x-axis label, the y-axis label, and the gg title. And finally, I've saved everything to this variable which is known as p, and I've printed out a ggplotly uh, object, which is an interactive histogram. And when I run everything in this, I can do it all together as well, and you will get the same graph. Okay. When you use ggplotly, it will take a few more seconds as compared to your gg the simple graph, but the overall graph will be much prettier. Okay. Now, what I'm going to do is I'm going to have another qualitative variable. Rather than going through this code, let me do something else. Let's use the I'm going to draw a graph like this, right? But rather than using it through the mpg dataset, let's use the gapminder dataset, which we already had, right? And we have this dataset which we already used. This is the head of that dataset. uh, let me draw the histogram for life expectancy. Let me see how it looks like. It may take a few more seconds because this may be a larger data set. So bear with me as the histogram for the Gapminder dataset life expectancy loads. Now this is the dataset. Now this is the histogram with nicely labeled x and y axes and the titles, as I explained. What I'm interested in seeing how the distribution of uh, different continents vary. And before I move forward, I think there is a question related to, please show the code of making histogram again, the first step, and explain the code. What does mpg stand for? Okay. Okay, let me go to that section of the code. Okay. As I explained that when you're making a plot with ggplot2, you're just making it incrementally. For example, this portion of the code, you are using the ggplot function from the ggplot2 package, and mpg is nothing but your data set, and uh, hwy is the variable in the data set. So these are the two things. You can take this code and just modify these two things in your data set, like in your code, which means that you will have to use your own data set and specify the variable in which you are interested in. And what this piece of code will do is make an empty canvas, and when I print it out, it's not showing me anything, right? But when I add the geom underscore histogram to this p variable and assign it to the same p variable and print it out, it is going to print out a histogram for me. But now what is happening, the histogram does not have x and y variable. So what I can do with the saved p variable, I'm going to add the x label, y label, and the gg title as well. So I'm going to add the x label, y label, and the title, and just print it out. Okay. So, and as I told you that with a very simple step, you can convert this uh, non-interactive our graph into a very better looking interactive graph. And let me show when it prints out. You can see, you can hover over it, and you can see the counts and different things, and you can zoom into any portion of it, and there are a lot of functionalities which you can explore in this graph. You can see things over here. Okay, so if you hover over it, there are zoom, and there are box select and things like that. You can zoom in, zoom out, and there are many other functionalities which you can explore on your free time. And our so mpg, your question is what is mpg? Mpg was the name of the data set, and what I'm interested in is move towards the gap minded data set to make a graph like this. And this is the head of the gap minded data set. Okay, and now what I'm going to do here with this piece of code is, as I told you, that you can do whatever I told you in a single line of code, right? uh, right now what is happening over here is, I'm using the ggplot function and taking the gap minded data set, and I want to find out the histogram. I want to make the histogram for life expectancy, right? And so what this piece of code is doing, let me select the piece of code. This piece of code is doing is select uh, the gap minded data set and select the relevant variable, which is the life expectancy, and make an empty canvas, not a histogram. And then the subsequent portion of the code is adding a histogram on top of that canvas, right? And then, like, I can keep on adding things, right? The next portion, what I'm doing, I'm adding the x label, I'm adding the y label, I'm adding the title. That is the whole. And then finally I'm saving everything ggplotly function to convert the p, which is a non-interactive graph, into an interactive graph. And let me run it over here. It will show, as I told you, that it takes a few seconds to load because the interactive graphics take a few more time. Now you can see it's a very pretty looking graph, right? I can do one thing more. Another thing is, I'm interested in the distribution of the life expectancy by continent, right? So what I can do that is very simple. Rather than first of all going before going that, I can do a few more things. Uh, if I'm not satisfied with the way that plot works, is I can, like, let's assume that I just want to make the fill of the graph white and the outline as black. What I have to do to make a graph like this, within this geom underscore histogram, uh, you have to put in color is equal to black and fill is equal to white. With this simple manipulation of the previous code, you'll be able to make a graph which looks like this, and you can choose any color which you want for the fill and any color which you want for the outline. The next line, what I'm doing, what I'm interested in is, for whatever reason, I'm interested in making a vertical line on the x-axis, right? So a line I want to draw which should be vertical to x-axis for some communication or demonstration purposes. So what I'm doing right now is taking the same p which I've saved to this plot, the code. This p has the plot of the histogram. What I'm doing is adding to that geom underscore vertical line, which is v line, and within that I'm specifying the details of the x-axis, right? And I'm specifying the color of this line to be blue and the line time to be dashed and size is equal to 1. And I just print it out. I added to the previous graph and just print it out, right? And see what happens. And see, there's a beautiful vertical line to the point which I specified, uh, which is the 50, the point on x-axis which is 50, right? And let's assume that I wanted to uh, I do not want to hard code the number 50, but what I am interested in is to make this line at a point where there is mean life expectancy. How I can do that? I can also do that with the same function, with the same code, but here I just change the x-intercept is equal to mean life expectancy. So it will automatically calculate the mean life expectancy, and it will automatically draw the v line to the mean life expectancy and just print it out. I'm moving a bit fast on this session because there's lesser time and a lot of topics that needed to be covered. But I hope I'm able to communicate what I want to. If not, you can ask me the question. But if you can see that the mean life expectancy in this data set is a bit lesser than 60, and a dash line is calculated at that point. Okay. So what else am I interested in? What I'm interested in the same histogram. Just want to find out. I want to get a overall histogram as well, and at the same time, I'm interested in making a histogram where the fill inside the histogram is equal to, like, gives me information about the continent. So after x is equal to life expectancy, I'm going to put in fill is equal to continent only, which is continent is another variable, right? And then I just print it out with this small modification. Let's see how informative our graphs get. Let let's wait for it. See, like, you can see how there you can see the overall distribution of the variable, and you can see how the individual variables are distributed. And because this is an interactive graph, you can hover over individual points and find out what is going on, right? And what now I'm interested in is, okay, this for me, I assume that this is quite, this may be not very clear, this may be confusing, that what's going on. I want to draw histograms for all the continents separately, and I just want to do that with a single line of code. So for the previous line of code, what I do, I just add one more argument or one more line of code, which is I just add this facet underscore wrap, um, and put in the name of the variable on which I want to make the histograms, and use this tilde and name of the variables, and give the number of columns is equal to, which I'm going to explain in a minute what that will do. And let's run this function. Okay. So what it is going to do, is now you can see that because we specified the fill equal to continent, the color of the histogram is also specified by the continent. That's one thing. But what is happening that for each continent you have different histograms, right? So with this facet underscore wrap, what you have done is you have made different histograms for at the level of the continent, and you have specified the number of columns equal to 2. So what I'm going to do over here is to this gives me a very uh, uh, different type of view. And if you want to like compare the performance on different uh, uh, qualitative variable or categorical variable, you can do that. Okay. So if you're not clear on this, I understand that this may be intimidating, but I would emphasize that you go over it again, and if it's not clear, just ask question and do it on try it on your own time. It is not as difficult as it sounds like. Now the next, what I'm going to do very something very interesting. Let's assume somebody says, okay, I'm not understanding anything, right? I'm not able to understand what you're saying and what you're doing and how would I do it, right? I'm just going to make the job very easy for you. If you are a person who says that, okay, I do not understand anything, I'm going to make a function and you do not need to understand this function. I'm just going to run it. You just need to understand that you will have to run this once, this piece of code. When you're adopting what I'm doing, what I'm telling you, what next you have to do, right? Okay. So the next piece, let's say some of you says that, okay, this is quite difficult for me, I cannot follow, I will not able to follow it. For the timing, what you can do is use these 3 lines of code and just understand them, and you will be able to understand, and you will be able to make uh, a similar histogram if you run the previous line function, like the previous code chunk function, this one, and then run this line of code. So let me explain what these 3 lines are doing, right? The first line is assigning the data set to the variable data. The second is what it is doing. It is, let me actually run this, type the second one so that I'm able to explain it properly. So what it is doing, it's taking the gap minder data set with the help of, right, when I put in dollar, like I type in the gap name of the data frame and then type the word dollar, then it will open a drop down menu which will specify the number of columns in there, and I choose the life expectancy column. So what this line is doing is taking the gap minded data set and selecting the life expectancy column from it, and what I wanted to do is to assign it to the variable x, and that's it. That's all I want to do, right? So I run these 2 lines of codes, and then I just use this function which I just made, draw a histogram, and just give, you just need to run it, you don't need to do anything else, and it will automatically draw the complicated, it will just, not the complicated but multi-line code which we saw over here, that is just embedded in this 1 line of code, right? Whenever you want to use the same code again, you have to specify, you have to change the name of the data frame and then the name of the variable on which you want to, for which you want to make the data, the histogram, and you just need to run it like that, and you will get a similar interactive histogram. So that is a simple, you can call it as a function I've made for those who might think that this is quite intimidating and I'm finding it difficult to forward, follow, and those I've made this function. Okay, what is the number of column is equal to 2 here? Okay, so I got what you mean, and let me move forward over here. Okay, okay. So as you can see, your question, Salima, refers to this plot, and if, and let's see. So your question is, what is this number of column equal to 2 refers to? So let's see. I put in number of columns is equal to 1, right? Right now, the way it was run previously, see there are 2 columns. All of your histograms have been arranged in the first column and then in the second column, right? So let's see if I put in the number of columns is equal to 1. And rather than explaining it, if I'm able to show you visually, then you will have a better idea what does it mean. Again, it is going to take a few seconds. Okay, so you can see that now all the histograms have been arranged in one single column, and this look is not very pretty. So I mean, that is stretched out. The graph doesn't look pretty. So that is something which you will want to play around with it. So rather than that, I'm going to move it here and just like type number of columns is equal to 2, and all the graphs will get organized in number of columns is equal to in 2 columns. Okay, so right, so this is how it goes. I think we have hit the 1 hour mark here, but I have to complete this session. Those of you who feel that they want to go, as I committed that I will be conducting a 1 hour session. Those of you who won't feel that okay, you want to go, you feel free to continue or feel free to go. I'm going to continue over here, and you can see it later on your own time from the recording of this session. Hassan, Dr. Hassan, do you want to stay or you want to go? What is your status?
Sir, I can stay for next 15 minutes. I can.
Okay. I will complete the session, and if you want to go, just feel free to just log off, and later I can take on the session myself. I think there is
Sure.
not a lot of synchronized attendance because of Ramzan. I think I'm assuming, so that's how I have to actually complete what I have planned for today, so that because there is not a lot of
Sure.
time left in these sessions, right? Okay.
Sure.
Okay. So I will move forward. Uh, So this is the function which I told you about, and this is a single line of code. There are 3 lines, and it will essentially do this, make the same histogram. Okay, okay. So additionally, what I've um, done is that okay, if you want your histogram to you want to use the same function, but you also want to add uh, the X label, Y label, and title to it, you can also use this line of code and just modify your X label over here. Like you can modify this X label, this Y label, and this title on the basis of your need, and then you can run. And at the same time, as previously, this portion remains the same, which is the name of the data set, and the x-axis variable, this will remain the same. And if you run the whole of this code, it will have a very beautifully specified x-axis label, y-axis label, and the title for you. And again, it is going to take a few seconds, but with the help of this function, you can make this x-axis, y-axis, and title. Okay, so I'll move forward. Okay, okay. So the next step is to okay. The next thing which you want to do is to make a scatter plot. And again, I'm going to use this MPG dataset, and with the logic remains the same if you're making a scatter plot. Now, but this time, because a scatter plot is a plot which compares 2 variables, and one of the variable is on the x-axis and another variable is on y-axis. So first of all, with the same logic as is used by ggplot2, you will make an empty canvas, and you will use this ggplot function, and with that you will specify your data frame or the data set. Then within this aesthetic argument, you will specify what is on x-axis, which is displ on x-axis, and on y-axis you have highway, hwa, and just make it print it out. There will be an empty canvas, as I said, right? And what I can do is to now this time, because I'm making a scatter plot which has points, The scatter plot, as you know, will have points. I will use this P and add geom point to it and assign it to the same variable P and then print it out. So now you'll have a scatter plot. And in the same way, as I said, and the rules apply in the same way to scatter plot as well. You can specify the x-axis label, you can specify the y-axis label, and you can specify the title with the help of this piece of code. And you have beautifully labeled scatter plot, but it is not interactive. In order to, okay, we can do something else as well, because it is scatter plot. You can add a linear regression line. And what you do with the previously specified scatter plot, as shown with all the labels and everything, you can add on top of that a geom underscore smooth with method equal to lm, which is a linear model, and then print it out. And here what will happen, that you will have a this line which is linear model, which is specified the linear model with the confidence interval specified by the standard errors on the basis of the relationship between displacement and high miles per gallon. Okay. And now I want to make this graph interactive. I will use the ggplotly function to make an interactive graph out of it. And as I told you that this is going to be a bit slower when it loads. It's going to take a few seconds. And see, now it is an interactive, and if you hover over any point, you will see, okay, or even the line, the standard error, you will see in the labels over there, right? So this is very cool way to make a scatter plot. Okay. Now moving forward, whatever I did in the previous lines of codes in the separate code chunks, I can do that all together over here in one line, and I will get the same code. I will get the same graph. Okay. Now I'm going to use the Gapminder dataset, and let's see the head of the Gapminder dataset, right? This is the head of the Gapminder dataset, and what I'm going to do is to make a scatter plot between GDP and the life expectancy, where GDP is on x-axis and life expectancy is on y-axis. And I'm using the Gapminder dataset for 2017 only, right? And I've made the x-axis and y-axis label over here, right? So let's make this graph, and let's see how it looks like. Okay, so this is now because this is the, let me just show you how it looks like. This is the scatter plot, and this is the scatter plot which we have right now. And what I'm interested in is coloring these individual points on the scatter plot with the help of the continent. So I can do that with the help. Before I do that, I'm going to use, I can make a smooth, I can use geom underscore. I can add the geom underscore smooth to the previous graph and see how is the regression line looking like in my graph. Okay. Okay. So here's the graph with the regression line. And then now what I'm interested in is that for each point, I want to find out whether to which continent does that point belongs, because each point is a country and want to find out to which continent that belongs. So with the very simple manipulation, as you can see, I've removed the geom underscore smooth because I'm not going to print out the line, the regression line for the points at this point in time. But what I'm interested in is that each point to which continent the individual line the point belongs to. And I'm going to add another small argument, which is color is equal to continent, and the continent is the name of the continent right? And I'm going to print it out. I'm going to run this code. Okay. So you can see now the dots have been colored on the basis of the names of the continents. The next thing which I'm interested in, because each of these dots are the countries, I want to make their size reflective of the population size. So I can do that as well. Or rather, before that, what I'm going to do is to add the regression line for the individual countries. You'll see that how that look like for the individual continents. Sorry, and you can see each continent has its own regression line, right? Okay. Okay. So as I told you that what I'm interested in for each of these points, I want to find out. I want to make the size of these points reflective of the population size. So for the previous code, what I can do is where I added color is equal to continent, I'm going to add another argument which is size is equal to population, this argument, and everything else remains the same. Right. I'm going to run this piece of code. And now in this graph, there is a lot of information. There is, oh, I'm sorry, I actually forgot to change the x and y axis labels. That is the same from the previous graph, which you can change easily. So I apologize for that, but you get the idea. This graph is between the GDP and the life expectancy, uh, and the color is shown by uh, the color is showing the continent, and the size is showing the population of the country, and each dot is a country. So again, I've forgotten. Let me just correct it over here. And the x and y axis label. The x label was uh, the y axis was. Let's see. And I'm going to modify the title as well. So now what I want to do is to make, as we did for the histogram, I can use the facet underscore wrap option to make separate histograms for each continent. Okay. And I'm going to run this piece of code and see what happens. See, like just as a histogram, we have scatter plots made for individual continents with their regression lines. So these are the types of manipulations which you can do easily for with the help of your ggplot2 uh, library, and these are quite easy to do. So there is a question again. Salima is asking, please explain the code for scatter plot. Okay. So the code for scatter plot is over here. As I told you that you will be able to make it incrementally as you did it for your for the histogram. That's how ggplot works. So this portion is just making an empty canvas. Rather, let me explain a simple scatter plot first, okay, rather than talking about the complicated ones. So let's talk about this one. This is a simpler one. So what I'm doing over here is taking the MPG data set, which is here, putting it in the ggplot function, and specifying the x-axis equal to displacement variable, y-axis equal to highway variable, and then specifying the geom point will add on the points. The smooth geom underscore smooth will add the regression line, and then we have to put in the x-axis labels, y-axis labels, and the gg title. And then I save everything to this variable p and print out uh, the scatter plot. Okay. And as I told you that it takes a few seconds to load because the interactive graphic is different. Okay, so this is your scatter plot. Okay, so let me move down where I was initially, where we were using facet underscore wrap to make a scatter plot like this, right? And what we did was that so let me explain this piece of code once again as well. What I'm doing over here till is that I'm using the ggplot2 function and using this data frame gg gapminder underscore 2007, putting gdp on x-axis, life expectancy on y-axis, specifying the color is equal to continent, and then using the geom point to make a scatter plot, using geom underscore smooth to make a regression line, facet underscore wrap with columns is equal to number of columns equal to 2 to make a multiple scatter plots on the same graph, and then makes label it on x-axis, y-axis, and gg title, make a title of it, and then print it with the help of the ggplotly. When I run it, then you'll get a plot like this. Okay, moving forward. With this, in the subsequent code, what I'm doing is not very much. There's not a lot different, but I'm specifying the standard error is equal to false. What that will do is remove the standard errors from these regression lines. So it you will have the option to keep the standard errors or not keep the standard errors. And okay, so then right. And for the scatter plot as well, as I made for the histogram, I've made a function, and this is the portion which you, if you do not want to understand, you do not need to understand it at this stage. You just need to run this function. And this is for those who think that, okay, I'm not able to understand what you mean at this stage. Still, this is a portion of this talk can be adopted for you. What you need to do is to, first of all, after loading all the libraries which I've said, which I've mentioned previously, load this, run this function, and which is draw underscore scatter function. And what you need to do is to just give these things as I specified previously. Given the name of the data frame which you are which you are giving, like here gapminder data set, save it to data. Within the gapminder data set, I'm putting GDP per capita on x-axis and life expectancy on y-axis. You can just choose whatever variable you want to put. And as I told you that, okay, like for you, first of all, you need to enter the name of the data frame, then the dollar sign, and then the name of the variable which you are putting in to x and y-axis respectively. Then you have to enter the name of the label of the x-axis, label of the y-axis in the title, and then after you do that, you just need to run this code, and you will be able to make beautifully looking interactive ggplot2. So, see, with this line of code, which I think is much simpler and maybe easy to use, you can run it. I'm sorry for this. Let me just silence my mobile phone. Okay, so the last portion which I'm interested in is to make a line graph. Okay? So what I'm interested in making, I've loaded the gap minder data set for Pakistan only, where I've specified the country equal to Pakistan only, right? And with the help of the same code, what I'm trying to do is take the gap minder data set for Pakistan, which I just specified. Uh, I'm putting year on x-axis and GDP per capita on y-axis. And rather than geom underscore point, I'm specifying geom underscore line. And just like a scatter plot, the same similar plot will be drawn, but this time it's a line graph. And let me load it. Okay, so now a line graph is made. And this time again, it's an interactive line graph. Because if you hover on any point, you will be able to see, okay, which time and GDP it corresponds to. Okay, we have another data set which we made initially in the start of this demonstration, which was for India and Pakistan. I'm not going to go into details how we made it, but this is the head of that data set. I'm going to use the same data set to make a comparison between India and Pakistan. And what I'm going to do in this line of code is use this India-Pakistan data set for Gapminder, specify year in the x-axis and life expectancy in y-axis. And this time I'm adding another argument, which is color is equal to country. Now everything else remains the same as I specified in the previous. I'm going to run this piece of code. And so now we have a comparison for India and Pakistan in terms of life expectancy, and you can just make comments on these findings. So this is all which I had for the time being, as I ran quite a lot over time, because there was a lot of material to be covered. If you have more questions, please ask in the comments. And Salima was once again asking, what is method LM? Method is equal to LM and standard error is equal to false. Let me go to that portion of the code. So here, so this method is equal to LM is specifying in the geom underscore smooth, you're specifying method. When you say method is equal to LM, it means that linear model. You can specify other models as well, like you can use polynomials or other models, but right now we are using the linear model. And standard error is equal to false is that when you make it standard error is equal to true, which is, I think it is the default status, it will print the confidence interval as well. So let me do that. If I put true and now run it, that you can compare the two. Okay. Okay. As I told you that this is going to take a few seconds. It's taking longer than expected. Oh, let me adjust the screen like this. I'm sorry for this. Okay, so now you can see that you have the confidence intervals as specified with standard error. Now if I change the standard error is equal to false over here and run it again, the confidence intervals will be removed. So now you do not have any confidence intervals. So I hope I was able to answer the question. So can we add colors to the line, etc.? So yes, you can add colors to. I'm assuming you're talking about the line graph. If not, so just let me know. Yes, you can. If you're asking about like, okay, you can add other colors to this line. Yes, there are so many details related to this GG++ lot to package that it is not possible to cover all of them in a very short session. As I have repeatedly reminded that these sessions are supposed to be giving you a broad overview, and I intend to conduct more sessions where I'll be focusing on different uh, specific areas. But yes, you can do a lot of these things. You can add colors of your choosing. You can play with it in a number of different ways, which I will be teaching in my subsequent sessions. So with that, if there are not a lot of questions right now, I will call this session off. Thanks a lot for those who have uh, been with me as live audience for this session, and thanks. I will also be thanking those who would be watching the recording of these sessions. Um, if you have not subscribed to my YouTube channel as yet, I will request you people, everyone, to please subscribe to my YouTube channel, and do not forget to press the bell icon. Please provide feedback for these sessions in the comments of this video, and take care for the time being. Bye and Allah Hafiz.